All right. So anyway, with theoretical and experimental probability. So we're going to compare what the difference between those two are. Okay? And then we're going to use that information to predict what's going to happen with a larger group. All right? All right, so the first one, this is kind of the definitions. I'm not really too worried about this uniform one. Uniform and theoretical are pretty much going to be the same thing. But a probability model is that every single option you have is going to have the exact same chance of happening. Okay, yesterday when Mr. Rourke was talking about that dartboard, Mr. Rourke's pretty good at darts. So when he throws it, he has a pretty good idea of where it's actually going to go. Not just
triple 20 most times.
All right.
Yeah.
And for me, it's like we didn't even include the wall behind the dartboard. Okay. But for uniform probability, each number has an equal opportunity. For theoretical probability, it's pretty much the same thing. Okay. That's saying what should happen. When we do this experiment, what should happen? Okay? And then the experimental probability is what actually does happen. Okay? Theoretical probability is going to be like the pretend like inside your mind the way it's should work. This is actually going outside and doing it. Okay, that's what the experimental probability is. All right, so I'm going to look at this very first one before I even scroll down to look at that theoretical or experimental probability. We have a dice. I'm going to scroll over here. I'm going to go right there. I've got a dice, 6-sided. What are my options for rolling on a dice? I can do a 1, a 2, a 3, a 4, a 5, or a 6. Okay, I'm gonna do this real quick. So what's the probability of me rolling a 1? 1 over 6. 1 out of 6 chance. Which converts to, if I want to do a percent, I'm going to do 1 divided by 6, which converts to a 1 or 17% chance. Okay, what's the probability of me rolling a 2? Still 1 out of 6. There's only one side that has a 2. So it's still 1 out of 6 or a 17% chance. What about a 3? 1 out of 6 or a 17% chance. Probability of 4. 1 out of 6. You guys kind of see what's happening with this theoretical probability? All of these ones should be the same because prior to rolling the dice, okay, prior to rolling the dice, that's what should happen. Also letting you know I rounded each one of these. That's why these will add up to over 100%. It was 16.6 repeating percent. Okay, so that's my theoretical probability. In theory, in my mind, that's what it should be. We're going to look over here at this dice that was rolled. So here's where all that information, that mean, median, and mode comes from. We roll the dice, and every time we roll the dice, we mark down what we got for our answer. So they rolled 1, they put a tally. They rolled a 3, they put a tally. They rolled a 2, they put a tally. For us to figure out what their percentages are for the experimental probability, the first thing we need to do is find out the total amount of choices out of all the experimental things that happen. Okay, so for me to figure out the total amount that happened, I'm going to add up every single frequency. So 6 plus 4 is 10, 8 plus 2 is another 10, so I'm at 20, 21, 22, 23, and I got 29. If you put on your calculator, you do 4 plus 6 plus 2 plus 8 plus 3 plus 6, it should end up with 29. Anybody get something different? Okay. So my total number is going to be 29 for my entire thing. So when I make my fractions, that will be my bottom number. All right, so looking at rolling a 1, what was my experimental probability of rolling a 1? I'm going to have that 4, because I had 4 right here, out of 29 total rolls. So again, I'm going to write down what we had for the frequency out of the total number that we did at the bottom. So I have 4 over 29. And if I want to write that as a decimal or a percentage, I'm going to take 4 divided by 29. And I get, it's 13.79. So I'm just going to say this one's 14%. Okay, and I look at number 2. Number 2, my experimental probability, I'm going to take this. This will be my top number. So I've got 6 out of 29. So 6 divided by 29. This new new experimental number is going to be 21%. Okay, for number 3, what do you guys think I'm going to put down for my fraction on that one? 2 over 29, fantastic. I got 2 over 29. So 2 divided by 29. It's just 7%. Yeah, you got to move that decimal spot 2 over. Yeah, so I got 0.068. So yeah, you're right. Got to just move that decimal 2 spots over. Number 4, 8 over 29. So 8 divided by 29 gives me a 28%. For the next one, 3 over 29, which gives me a 10%. And then 6 over 29, perfect, 21, because we had that one before, fantastic. Okay, here's what my actual experimental probabilities were. All this was my experiment. All this stuff over here was my theoretical. Do these numbers match up with these? No, they do not. Okay, so I'm going to look at the experimental probability of rolling a 4. For the experimental probability, what did I have? What was my percentage of rolling a 4? Which one was it? So 28. I had a 28% chance in my experiment of rolling a 4. In my theoretical, what did I have? 17. So when I rolled the dice, did I have a better percentage or a worse percentage than what I thought I should have had? A better, because the number was higher. Okay? The nice thing, I'm going to say nice thing about this, is that the more samples you do, the closer it should get to this. Okay? If you had I'm going to use a coin. Okay, real simple here before I get this one. If I have a coin and I have the option to flip the coin, what are my 2 possibilities? Heads or tails. So what's my percentage of getting it heads or tails? 50%. If I only flip the coin one time for my experimental probability, okay, if I flip a coin one time and it lands on heads, and that's the only sample I do, what was the probability of getting a heads? That was 100%, because I flipped only one coin and I got heads. Does that make sense? So again, the experimental is going to be a little bit different because theoretical is what should happen. The experimental is what actually does happen. Okay? So we're going to do this one. I'm going to kind of show you this one. It's a kind of a simpler one. We don't have to make the tally mark for it. But this one says a coin gets tossed 40 times. Heads comes up 18 times. Find the experimental probability of getting tails. So let's just do my 2 choices here. I've got heads. I've got tails. Because I'm going to kind of make it similar to what we did before. How many times did it come up with heads? 18, which tells me how many times did it come up with tails? 22 times. How'd you get that, Lawrence? Subtracted. Yeah, out of 40, you took 40 minus 18, and you got 22. So my total, I'm going to use my total here, is going to be what number? 40. Fantastic. So let's look at kind of that chart that we just made. Now let's put together some experimental probabilities. What is my experimental probability for heads? 18 over 40. Fantastic. Now we're just going to simplify it down so that way we don't have to do all of them. You can divide both of them by 2. So I get 9 over 20. Okay, what's my experimental probability for getting tails? 22 over 40. Simplified down. 11 over 20. You either divide both of those by 2, or you can see that both of these will add up to a full, top numbers both add up to 20. Okay, so here is my experimental probability. Okay, so here's my experimental. You guys already told me what flipping a dice would be. Theoretical, what should my probability of getting heads be? 50% or half the time. Half the time. So 9 over 20. I'm just going to change that into a percentage. You got it. 45%. This one will be 50% or 55%. This one over here is going to be 50. And then 50%. It says compare the experimental probability with theoretical probability for getting tails. So let's look at tails. What's the experimental probability of getting tails? 55. Okay. What's my theoretical? 50. Am I doing better or worse?
Better.
I'm doing better than my theoretical probability. Feeling okay? Again, that's the big difference between theoretical and experimental. Theoretical is the stuff we did yesterday, where we just kind of put the fractions over each other. The experimental is what we actually do. Okay, this is one. We'll do this one together, and then we'll jump on to where you guys will work on your own. Thank you, ma'am. All right, so for this one, it says the table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Okay? What's my bottom number for each fraction? 200. How'd you get that?
It's the total of teams.
Yeah, it tells us the total is going to be 200. If you wanted to, you could add every single one of those up, but the great news is the definition on that one says it's going to be out of 200. Okay, for each one of these, we're going to do the exact same thing. We're going to change them into percentages, and then we'll be able to kind of go on to this next part where we make a proportion. So somebody talk me through. Just one person talk me through. How do I get my fraction for watching TV? So you said 50 over 200. Am I done there, or do I have more? Okay, I can simplify it. Both of them by 50, so I get 1 over 4. What would that be as a percentage? 25%. Okay? Listen to music. Somebody new. Talk me through those steps. Austin? Okay? Can I simplify it? Yep. Yeah, they're both even. Okay, so I can divide both of them by 2. So I get 26 over 100. Or sorry. Actually, yeah, it does 26 over 100, and I can simplify it again to 13 over 50. But this one simplifies down to 26%. For these ones, I'm really just going to be focusing only on the percentage. So don't worry about the simplified fraction. We'll do the fraction first, and you just change it to a percentage just to make things go a little quicker. All right, 54, or next one has 54. Somebody brand new, tell me my percentage. Or sorry, yeah, fraction, then percentage. Luis. Okay, 54 over 200. What'd you get for a percent? Okay. 27%. Perfect. Somebody new, reading. What's my fraction? 18 over 200. Okay, what's that percent?
Or
9%. Okay. Okay, next one, write or draw. Anybody? 10 over 200, which is 5%. And the last one, other.
16 over 200.
Awesome. And what do I get for that percentage?
8%.
8%. Okay, every single one of these was, I kind of have, it says 25, 26, 27, 9, 5, and 8. What we can do is, now that we figured out what these percentages are, we can use that data to figure out stuff for way bigger groups. So this is only out of 200 people, that first survey. But it says out of a similar group of 450 teens, predict how many would listen to music. Here's how we figure that out. We take our group size times the percentage as a decimal. I'm going to put it over here.
take the old group size or the new group size?
The new group size. Good point. So we take the new group size times the percentage when we write it as a decimal. So for this one, my new group size is going to be 450 times. It says listening to music. What was my percentage for listening to music? How do I write 26% as a decimal? 0.26. So I'm going to take 450 times 0.26. 450 times 0.26. I find out that there should be, in theory, about 117 students or teens that listen to music. Did that make sense on how I did that? Again, I take the new group size times whatever that percentage was as a decimal. Okay, so this one, part B, I want you guys to do this one on your own. It says out of 450 teens, how many would you expect to be writing or drawing?
So you run the linear percent.
Okay, yep. Remember that percentage has to be at the decimal. Move the decimal spot over 2 spots for the percent. That's what we should do. Not quite. We'll go for writing or drawing. Choose this percent color. We're going to do big group size. You should type it. You write it up that way. The group size times this is the decimal. What's 5% of that? Just step by into that single decimal. What is 5% of that? So move that decimal spot over 2 spots. All right, so the numbers we should have been multiplying. As you put them on your paper, I'm just going to write them down first. And again, if you guys get stuck with these ones, write the steps down. Okay? So I have 450 because that's my new group size. Times, it was 5% from up there. So when I write that, 5% is going to turn into 0.05. Because again, if it was 5%, I move the decimal space over 2 spots. So 450 times 0.05 gives me 22.5. Okay? I got some good news for all of you. Great news for society. We don't have half people. Okay? It'd be like a person chopped in half would be real weird. Okay? So I can't have half a person. So looking at these ones, I'm still going to round to make sure. Because again, we want to figure out how many teams would actually be writing or drawing. So on this one, I'm going to round, for this case, up to the nearest person. So I would expect 23 teens would write or draw. So they would write or draw. Does that make sense on what we did? Again, we take that new group size times the percentage that we got from that whole entire group. Okay. This last one I'm going to do real quick. I'm going to kind of show you the good news is they already put this thing together. It said, I'm going to write the numbers. It says 44% preferred football. So again, if they give you this data stuff here, we can make our own chart. It said 28% had basketball. It said 20% were in soccer or preferred soccer. It said 8% preferred tennis. The last thing that's saying out of 560 students in the entire school, how many would you expect to prefer watching basketball? How would I solve that? Someone can talk it out to me. Austin, what do you think?
560 times 0.28.
Fantastic. I got 560 times 0.28. Because what Austin did is he took my new group size times the percentage written as a decimal. So we did everything spot on there. So 560 times 157. Thumbs up, thumbs down. Where are you guys feeling? Okay. What you guys got tonight then? Page 479. I'll write it up here. 5 through 8. ALL. All. You guys got 4 problems, and they're all going to be just like this, where you get that experimental size, and then your job is to kind of convert it to that bigger group. Okay.